Hi, we are Group 15 from Section 16, and this is our project LED Control System for Mission Rescue Base. Our system simulates emergency light signal for a disaster response base. It has 3 modes, controlled by one button, and displays real-time status on the serial monitor. Our project uses 3 embedded peripherals, LEDs for visual alert signal, a push button for user interaction, and the serial monitor for real-time system feedback. These components are enough to simulate an emergency signal control system in a minimal embedded environment. The system is coded using C with struts, arrays, and loops. As you can see here, this is Mode 1 Emergency Beacon. The LEDs blink one after another using a for loop, simulating a rotating siren. You can see LED 1, LED 2, and LED 3 lighting up in sequence. Now switching to Mode 2, Rescue Pulse. All LEDs flash together like a distress signal. This uses a while loop. Finally, Mode 3, System Check. LEDs alternate using a do-while loop to simulate diagnostic. We use loops to control blinking patterns, struts and arrays to manage LED states, and the serial monitor to display status. The button cycles through all 3 modes. This concludes our demo. Now I'll explain the Arduino code that controls the LED patterns for our project. It uses strut, loops, and button input to manage the LED signals. We define a struct named LED that stores each LED's pin number and its current state. Then we create an array of 3 LEDs connected to pin 9, 10, and 11. Next, we define constant for the button pin and use variables to track the current pattern and the bounce logic to avoid multiple button detections. In the setup function, we set the LED pins as output, the button as input with pull up and initialize the serial monitor. In the loop, we read the button state and check for change. If pressed, the button increases and resets after 3. Then we call the correct pattern function based on the current mode. Pattern 1 uses a for loop to turn on one LED at a time in sequence, like a rotating emergency beacon. After each LED is turned on, the system reports its status via serial. Pattern 2 uses a while loop to flash all LEDs on and off together. This simulates a rescue distress pulse. The status is also sent to the serial monitor each cycle. Pattern 3 uses a do-while loop to alternate between 2 LED combinations. LED 1 and LED 3 turn on, while LED 2 is off, and then they switch. This simulates a system diagnostic suite. Next, we created utility functions to simplify the code. The set status function prints the current mode and the state of each LED to the serial monitor. This helps monitor the system remotely and debug if needed. Our program is structured using modular code with clear function prototypes and separation of logic. We use all 3 types of loop, for, while, and do while. Each type to a specific LED pattern. We also use a struct and array to manage LEDs, and the bounce logic for the button. This ensures our code is clean, efficient, and demonstrates good programming practice for embedded system. Each group member contributed to building and testing the code, including implementing the bounce logic and structured LED pattern handling using C-based programming best practice. So that's all for our group. Thank you for listening.